In this video, we will introduce you to the Program R and the Program R Studio, which is an interface for working with R. And before we begin with this video, we just want to make it really clear that you can't learn R in one sitting. We're going to provide a very general overview, and really, like all things, learning and mastering something new takes time and patience and dedication. We'll be following along a little tutorial called R for Fledglings, which is a document that's posted at a website. You can just Google R for Fledglings. It's written by me and my co-authors, who I'd like to fully acknowledge, Michelle Brown and John Katz. We are all with the Vermont Cooperative Fish and Wildlife Research Unit. I'm with the U.S. Geological Survey. This is an ebook, it's free, and this is an introduction. And I'd like to say straight off that this is not necessarily the best introduction to R. It's a booklet that we compiled for learning R and trying to teach R to natural resource practitioners. And there are many other books out there and many other people who are way more proficient in R than I am. My co-authors are very proficient in R, but this is just an example, a short, brief introduction of how to use R, and we will be following roughly the first 4 chapters of this ebook in our video today. The first thing is that you need to download R and R Studio. So you can find R at this link here, and then you can download that onto your computer, and then you can also find R Studio at this site right here. So if you go to the R for Fledglings book in chapter 1, it'll tell you how to download and install those 2 different programs. Now when you install R Studio, which is what we'll be working with, you'll see this general layout here, and it's divided into these 4 sections. This section is where you would write a script, which is just a text file where you enter in lines of code and then press the run button to run the code. The second section is called the Workspace and Environment and History pane. So here is when you run bits of code, you will produce objects, and those objects are stored in the environment. Those are things that R can work with. The History pane will let you find and retrieve bits of code that you had run in the past. When you run something in the script, what's actually happening is those lines are being sent to R, and this is what R is, the R console. And this is the program R that actually does any calculations and returns the results. So this is the main thing here. You don't need to use R Studio to work with R. You can run everything through the R console. I just find it's helpful to have this this kind of synthesized environment where everything is easily accessible in one spot. And then this last tab is where you can look at files, plots that are produced from your code. You can install different packages, which are like add-ons. You can get help, which is a feature we will use frequently, and you can use the viewer as well. So this is what R Studio looks like. And in this tutorial, we're going to start by opening up R Studio, and we're going to work through a script that we've put together to help learn some of the very basic parts of R. The second chapter of this R for Fledglings book is a tour of R Studio, and we sort of went through that tour. It will describe each of those different panes in detail. The third chapter describes functions in R, so everything that R does is done through a function, and the fourth chapter is about the different objects that R can work with. And as I said, R tutorial today is kind of a brief overview of these 4 chapters combined into one. So again, this is R for Fledglings, and you can find that on the website. So here we have RStudio. I have opened up RStudio, and I have opened up this script called Intro to RStudio. .r has a .r extension, so my computer knows that if I have a file that has .r at the end of it, it will open this in RStudio. You can retrieve this script from the website itself. And we are following the R for Fledglings, and for your reference, this is how you can access the Fledglings book. So this first part of the script, we are just going to write bits of code and then execute them. And the pieces of code that begin with this pound symbol are comments. Those are words that are not executed by R, but they're notes to you, the coder, about what different pieces of code are doing. And we are of the philosophy that you should comment heavily your code and make it as easy to read as possible, because there's a good chance that you won't be the only person reading your code. So how R works is you enter a function and then you pass in an argument. Just like Excel, we have a function name followed by an open parenthesis and a close parenthesis, and then the argument goes inside of that. And just to stress this point, we will bring up a spreadsheet and we'll just look for a function. So let's put in some letters here, A, B, B. And now let's use the COUNTIF function to return the number of A's that are in this vector. So we'll find COUNTIF. Here we're going to look for a function. It's called COUNTIF. That's the name of the function. And when we open this up, we can see that this function has 2 arguments. And you can see here's the name of the function, an open parenthesis and a close parenthesis. So the first argument we feed in a range, and the second argument we feed in a criteria. We want to count the number of A's, and I'm going to put that in quotes because it is a character. And you can see the spreadsheet is giving us the number 3. Well, that's exactly how R works as well. We have a function name, open parenthesis, close parenthesis, and the arguments go inside that. And a lot of learning R is learning what the function names are and then learning what the actual arguments are as well. So here is the square root function, and it's sqrt, and we are passing in an argument, the number 10. If we run this, this will be evaluated by R, and then down in the R console you'll see that it returns the result. You'll also see that this has the number 1 near it, and that's because this result here is stored as a vector. It's actually not stored by you yet. If you wanted to store the answer, you would do something like this. You would say answer, or something like that, answer is square root 10. Now if I run this line of code, R will find the answer and it will create a new object called answer, and it will store it in the global environment. And as a shortcut, so this can be difficult to write, there are shortcut keys in RStudio for quickly entering that, and that is that shortcut is the Alt dash keyboard command. So it's a fast way to make that symbol. So this is called an assignment operator, and so we are assigning this result to a new object called answer. So let's run that. And as you can see now, this object is called answer, and it's stored, we can see the value here, in our global environment. Now, I don't know if this is common convention or not, but I like to think of these objects like shoeboxes. This is the name of the shoebox, is called answer, and currently it holds this number. We open that up and we see the number 3.16 is in that shoebox. If I passed a different number, answer is the square root of 11, and run it, now my shoebox my object is still named answer, but now it's holding a different value in it. So this global environment is where the objects that are created are stored. And I really enjoy having this tab right here so that as I run a bit of code, I can quickly go and look and see what happened, what was the result of running that bit of code. Now there's a concept in R called the working directory, and that's just the folder that contains where R thinks you are in your computer. And the way to find the working directory for your session and your computer is to run the getwd function without any arguments. So that's what that looks like. It's just the name of the function, open parentheses, close parentheses. And you can see here that my working directory is set on my C drive, users, T. Donovan, blah, blah, blah. Introduction to R is the name of the folder that I am in. And we can also find that working directory by going down into this portion of RStudio and looking at the Files tab. So this is showing the file path. Of course, yours will look different. And this is the script that I have opened. So this is the working directory that I am in. We can also choose these three little dots here and use that to navigate to different folders. And if we navigate to a different folder and tell R we want to be in a different working directory, we can press this little wheel here and say set as working directory. And incidentally, when you run and click on buttons in RStudio, they're actually running our functions. So you should look at what happens in the console after you run or push a button. So if I say set this as my working directory, you can see that really nothing's changed because I was in the right directory, but you can see that this setwd function has been run, and now this is my working directory, which is identical to what it was. Let's look at this help tab in much more detail. Getting help is like the most important thing. I use this tab all the time. You can get help by using the help function, and you basically type in the word help, open parenthesis, close parenthesis, and then pass in the name of the function. Oftentimes in quotes. Sometimes I will be a little sloppy and not include it in quotes, and I'll find that RStudio has put quotes around it anyway. So that brings up the help tab. And the help tab here now brings up a bunch of different functions like absolute value and square root, and this is what a typical help page looks like. So the help pages for a function will give you the name of the function. It will tell you where or which package that function resides in. So this is a base function that comes with R. And this is the title of that. So this is miscellaneous mathematical functions. Then there'll be a section called description, and then a section called usage. So you definitely want to read through these. Square root computes the principal square root of x. And basically, the usage section will tell you how it's typically used. The user will enter the name of the function and then pass in something to be evaluated. We passed in the number 10 or the number 11. If you scroll down, you'll see another section called arguments, and that'll describe what each of these arguments are. So this says our x is a number or a complex vector or an array. And then the next section is called details. This provides more information about this function. It'll provide some references, and most importantly, it will provide some examples. And running these examples is one of the best ways to learn how to use a new function. My only complaint is that sometimes authors will not fully indicate the names of the arguments. So sometimes these examples are a little bit challenging to pick through. But you got to hang in there and at least run it, so they're meant to be copied and then pasted directly into your R console. So I've just copied that with Control-C, pasted it into my R console, and then ran that function. And that is the product of these lines of code. Don't worry about these yet. We'll go through some of these in more detail. But I wanted to make sure that you understood that the examples is a really important section of any help file. Now, another thing to point out here is that R is case sensitive, so capital help will not work. And if we run that line of code, you'll see that R will return an error. Could not find the function help. When you see an error like that, don't just blast through it, because taking your time and reading through the help file error message, even though it might take a second or two to slow down, this often will help you to understand why an error has been made. The help and then the help search function are really invaluable. So if we're looking for a function called meatloaf, we can type in the word help and then enter meatloaf in quotes. And here R is saying there's no documentation for meatloaf in the specified package or library. You could try this question mark meatloaf, and that is a shortcut for the help search shortcut. So if we tried that, help search meatloaf, this is invoking a keyword search, and R is not finding any hits for that as well. So this is looking for a function, and this is doing some sort of matching based on keywords. Let's take a look at the plot function. So here we'll run help plot, and here we can read through the plot help page. Plot, it has an open parenthesis, close parenthesis. We have to pass in the coordinates for the x coordinates and then the coordinates for the y coordinates. And then there's several other arguments that could be passed in as well. And these are things that will help to create the plot. If you scroll down, you can see some examples of different things here. And we are just going to run this plot. We're going to run the plot function, and we will sort normal random variables, and we'll use this this type of plot with this type of heading. And I don't want to go through the code here. What I really want you to just see is that when you run a plot function, the plot itself will appear in this plots tab. And you can scroll and see previous plots. You can also zoom into a plot, and you can export that plot as an image or a PDF, or copy it to the clipboard. You can delete it with this little broom here to sweep it out of the way. So the plots that are created are all sent to the plot tab. Now this next section is the global environment, and here's what I really want to pay some attention to: the objects that are created as we run different functions. So here we'll use the square root function, and we will pass in the square root of 10, and we'll save this as a new object called result. So here this result is stored. So this is the name of the object and its current value. And in running these other examples here, we have other things in our global environments as well. And this is telling you not only a glimpse of what is in the object or what the object consists of, but also its type. And I'll get to that in just a second here, but just briefly, this object called X is a vector that consists of 47 records, like a column in a spreadsheet that's 47 cells long, and it consists of numbers. This value called XX is a vector from 1 to 19, so just like a row or a column in a spreadsheet that consists of 19 elements, and this consists of just integers. There's no decimals involved. So the global environment, looking at this global environment after you run a bit of code is really key to jump-starting how you understand how R works. Now I want to take a couple seconds here to go through these RStudio settings. And the settings, you can see the tabs across RStudio, and I won't go into all of these, but what I want to point out is the Tools tab. There's lots of ways to edit your code, view the code, things like that, work with plots, build a package if you'd like to debug your code, and things like that. Here's the Help tab, and here you can look for RStudio support, cheat sheets, which I think are pretty handy for a lot of things that you might be working with. Keyboard shortcut helps, very handy if you're somebody who does not like to use your mouse all the time, and things like that. What I want to look at right now is the Tools tab and go to the global options just to show you that you can change how RStudio is configured. So under this you see the Options tab. Here is where R, this is where R, the actual program, is residing. So this is connecting RStudio to your R file. And for the most part I've left these all as default. The section called Code, this is where you can control how the code looks in your tab here, and how spaced it is and things like that. I've soft wrapped the R source files so that the code just automatically wraps around. I find that's a helpful thing. You can check certain arguments if you'd options if you'd like to. The one thing that I like to do is to go over to the Diagnostics tab here, and I like to check this Provide R Style Diagnostics, like including white spaces. And I'll show you what I mean by that in a second here. But this is a way to help keep your code really clean looking should you need to have other people look at your code. In fact, your organization may have some coding types of rules that you must follow. You can change the appearance of how your code looks, and you can change the theme for the editors. So some people like to have a black background with white type and different colored fonts and things like that. For right now though, I'm going to boost my size up a little bit and then press apply, and it will make my font here a little bit bigger. The pane layout just lets you organize these 4 panes, and also lets you determine which things appear, which buttons appear on each of these panes. Packages, here you can, and I'll cover this in just a minute here, but these are like add-ons. So they're like add-ons in an Excel add-on. They're things that run with R that other people have developed, and we'll make extensive use of packages throughout this course. These other things are for things that we won't necessarily use in this course, but if you like to write reports, R Markdown is a fabulous tool. Sweave is a way of also writing reports. Spell checking. Git is a way for you to share and store your code at GitHub. Is a way that would be important if you're, say, developing packages with multiple other people. It also lets you keep track of previous versions, so it's a way to control versions. So I'm going to press cancel on this now, and we will come back to that. But if you have some time, I would definitely poke your way around this toolbar and also look at these options in the global options. Definitely look at each little element that you can, just to have an idea of what's there. Okay, so now functions in R. That's our next topic here. And you'll see that my code, where I have indicated these long lines, it has this little drop down here. So I can shrink bits of code and I can expand it. And that's nice if you are dealing with a long script. You can basically create these little headers that will let you ignore pieces of code that you don't want to look at anymore and then expand them when you do. So I want to talk about functions now. And functions are everything that R does. It is done through a function. And what we're going to do is we're going to take pi and round it. And of course in Excel, that's the round function. Let's go ahead and look at this. Here we can say, we can pick a number. Let's do 10.444, and we can now round this. I'm just going to type the function itself. So there's the function name. Open our parenthesis. The first argument is the number, followed by a comma, and the second argument is how many digits do you want to round to. I'm going to put that to 2, and then the spreadsheet will return the answer. It's no different in R. We start off by this built-in object called pi, 3.141593. Now let's go look for the help page for the round function. So this is rounding of numbers. And there's several actual functions that work in this same help page. There's the ceiling function, the floor function, the trunk function, the round function, and then this is a significant digits function as well. These provide some examples of how these functions are used. So round x something, pass something in for x, and tell it how many digits there are. Now this usage is important because it is telling us that when we pass something into the round function, the default here is it's rounding it to 0 digits. This is something that can really trip you up if you don't know what the defaults are and you happily accept all of the default values and are unsure of what those values are. That's why it's important to look at the help page for the function, look at the arguments, and then also look at the default values. So here, now to use this function, we'll pass in pi, so we'll say round, and we'll say x is equal to pi, and the digits is equal to 0. So if we run that bit of code, you'll see that it is rounded pi to 3. Now I want to have you watch my mouse here down in the console as I run this function again. I'm going to start typing round, and now I'm pressing a tab, my tab key, and it brings up this little help, this little helper for me. So if I just now, I'm highlighted X, so I can just now tab again. I don't have to type it. Now I can type in pi, press a comma, tab again, and it filled in the digits for me because that's the only other option, and I can put in a 0 and run the function. So use that tab key because it really helps you to walk you through the different arguments. Now I could have just typed in round pi and I would have received the same result. Why? Because the default is invoked I didn't pass in an argument for digits, and so it used digit as 0 and it returned that result. Now, order is important. You don't need to name your arguments, but I will say I think it's really important to name your arguments. It makes it clear. It makes your code much more readable and more clear. But if you do not name your arguments, order really matters. So if we type in this, round 2, comma, pi, we're not naming our arguments, this is going to round 2 to the pi number of digits. And in this example, it doesn't make any sense. So that is, the order does matter, especially if you are not naming your arguments. However, having said that, we will try to name all of our arguments in our scripts so that it's really clear what is the argument name and what the argument value is. Let's look at another function. This one's called the sequence function. First we'll use help sequence, SEQ. This is a way to generate a sequence. Now, what if you want to generate a sequence but you have no idea what the function name is? Well, fair enough. That's a tricky one. And here you can use the help search idea, or you can look for Google. That's a very handy source of information for me anyway. But the help search is based on that keyword search, and hopefully you'll end up finding that. So this generates regular sequences. So it's a standard generic function with a default method. And here, if we look down, it provides some examples. So sequence from equals 1, to equals 1, by equals, and you have some different ways of using this particular function. So there are functions that have multiple varieties, if you will, ways of using that particular function. If we keep scrolling down, we see the arguments from, to, by, length out, along with. We see some more information in the details section and some code that explains some simple, typical ways to use this function. And then if we keep scrolling down, value will tell us how R returns that object, and then the all-important examples in the end of the help file is critical. So here we are going to run a sequence function. We're going to generate a sequence beginning with -9 to 9 by 1. And if I run that bit of code, you'll see that R has produced this sequence of numbers. Once again, let's do this in the R console using our tab. So we start the function. Now I'm pressing tab. Cut that. I don't know why this isn't working. Cut that piece. Now, functions in R are open source, and that means that you can actually look at the code that was written to execute the work. So as an example, let's look at the citation function. This citation function with nothing in it, no arguments passed into it, would return the way to cite R. And this is written in a bibtext entry type. So here it is, the R core team, and this is how you should cite R when you're using it in your work. Now that's the function. We've entered the name of the function and we passed nothing into it. But if we want to look at the code that is actually returning this information, we can just type in the name of the function itself. And here is the code for that function. This is the code that will return the citation given what arguments you pass into it. Now I'm not going to walk through this code, but I just wanted to let you know that you can always look at the code, and if you develop some proficiency in R, sometimes it's useful to dig into people's functions to really get a handle on what's going on. Now, functions can be nested to save room or shorten up your code, what have you. They might be more efficient. Let's look at the square root help page once again. And here we're going to zoom all the way down to the bottom, and we're going to run this bit of code that is in the, actually it's just these first 2 lines. So we're setting up a vector called xx, and here this vector is going to start with -9 and run to 9. So what is this? XX, let's take a look at it. There it is, XX, it's in our global environment. It's a vector of 19 elements, starts with -9, and it consists of integers. Well, we could have done the same thing with the sequence function, right? So this is another way of indicating a sequence. And now let's look at this plot, this next line, which is to plot it. We're going to plot XX against the square root of the absolute value of XX, and we're going to turn this into a red diagram. And that is what this line of code produced. It's in our plots tab. Now, this is tricky, right? I mean, a lot of the help files in R take advantage of this nesting, and to work your way through it, you need to first find the innermost functions. So the first thing that this function is doing is it is plotting XX. So XX is on the bottom axis, and this is YY. So if I were to make this a little bit more clear, I could have put the argument names in here. Plot x equals XX, y equals the square root of the absolute value of x. And of course that's going to give us the same thing. The only difference is that I've named the arguments so that when I return to this bit of code, I can clearly see what the arguments are and what their values are. Now this is nested. First we're going to take the absolute value of XX. So I'm going to copy that and put it into my console, and there you can see that XX, which started with -9 to +9, is now all positive. And now I'm going to take the square root of each of those. Square root. So I can save this as a new object, and we'll just call it new, just for a shortcut. Absolute value of XX. There it is, new. It's in my global environment now. And now we can take the square root of new and return that. And here we see our values. So this, we are plotting XX, which originally went from -9 to +9, and now we're taking the square root of the absolute value of XX. So that's an example of a nested function, and as I said, many examples in the R help files are nested like this, and to gain a full understanding of some functions, it might be necessary to pull these apart and break them down piece by piece. Okay, now let's talk about packages. There are built-in packages that come with R when you load R, and you can look for the packages in the Packages tab. So these consist of packages that come with R, but they also consist of packages that I have loaded in to my library. They're add-ons. They're not written by the R core team. They're written by other people. So one of the packages that comes with R is called datasets, and you can look for that in your Packages tab and find datasets. There it is, the R datasets package. And if you want to use this library, You can use the library command, or you can click on it and it will bring you to this package's help page. There's the description file, and here's a list of all of the data sets that are contained in this package itself. If we want to work with the chick weight data set, for example, this is weights versus age of chicks on different diets, we can use the data function to do that. And now you can see that in my global environment, chick weight appears, and it appears as a promise. It's there. It's not really there yet. We are about to start working with it, and as soon as we start working with it, we will see it in the global environment. Now we can use the head function to look at the first 10 records of this data set. And we can run that bit of code, and you'll see now chick weight is listed in this data section of our global environment. We can see that it is a data set that consists of 578 rows and 4 columns. If we expand this little button here, we get an idea of what each of the columns looks like and what type of information is stored. And I'll cover this in just a second here. We can also click on this little icon here, and that will bring up the data set in spreadsheet view. So here is our data set, and if we scroll down, we can see all of the records and get an idea of what this data set looks like. When I clicked on that, don't forget, after you click on something, just very quickly go down and look in the console. That invoked the view function, which brought up that spreadsheet-like view. So the head function is a way to look at the first top records of a data set. There's also a tail function to look at the last records and things like that. And in fact, we should go look at the head function. So we'll type in help head, and this will return the first or the last part of an object. It doesn't necessarily have to be a data set. So typical ways to use this, typical ways to use the tail thing, tail argument, tail function. You pass in an object, and then you tell it how many records you want to look at. So here we said head, x is equal to chick weight, and we want to return the first 10 records. If I had changed that to 6, then that would return the first 6 records. And in fact, 6 is the default. And you can see that by looking at the usage section here. Head, and here you can see n is equal to 6. Do you see that capital letter L there? It's a little bit hard to see. That means that that's an integer. So this is the default. If you just say head chick weight and don't put in this argument, this default will be invoked and it will return the first 6 records. So that's an example of a package that comes with the base program R. There's a handful of those. Those are the core functionality of R. But you can install packages that are contributed by others as well. And here you want to look at, go to the CRAN website and look under the packages. So I'll type this in and bring this up. So these are contributed packages on the CRAN page here. You can look at them by date of publication, or you can look at them by name. And there are now thousands and thousands of different packages that people have contributed. And we'll be looking at several of these throughout the course. But I just wanted to give you an idea of where these packages are. Each package consists of a help page that can be accessed through this website interface here. So here's one, Bayesian goodness of fit. Let's take a look at this package, If we click on it, you'll see it brings us up to this package page here. It provides you with the title, a short description. It tells you what packages it depends on. It will go through some basic information like who developed the package and who maintains the package. That would be the person who, if you find bugs or have questions, that's the person you would contact. The reference manual will provide the help pages in alphabetical order. What I like to look for are the vignettes, which are kind of user-friendly manuals that help walk you through things step by step. And then the actual package itself can be obtained here. But normally, how you would load a package is you would just do it through RStudio. So let's see how to do that. But before I do that, what I wanted to do is to mention that these packages are stored in what is called your site library, and that's different than the R core library. And you can verify this with the library function. This is just library, open parenthesis, close parenthesis. And if I run that, I can see on mine, this will be different than yours, my site library is stored on my C drive in a folder called R Site Library. I've intentionally done that. So these are the packages that I have downloaded and use in my work. There's a second library though, if we keep scrolling through. And these are the packages that come with the base. These are packages that come with the base R program. So these are in my program files. They're associated with R itself. So these come with R and are loaded by default. And you can see that many of these are statistics because statistics is the bread and butter of R. And although R is very good at doing many other things, its reputation is based on its statistical foundations. So you need to know that there are two libraries. You have the libraries that you personally add in, and you have the libraries that come with R. This .libpaths function will quickly just tell you where those two libraries are located. Here's where my add-ons are added, and this is my core packages. Now, if you don't know where R is located on your computer, you can use the r.home function and pass in no arguments. So this is telling me where R is located on my computer. Now, to see how packages work, we're going to use the install packages function, and we'll install a package called vegan. This is a package that we'll use in other videos. Now you can do the install packages function, or if you go to the packages tab, you can choose the install button and then just type in vegan, and once you find it, you can click install. And you'll see that it is asking you which library do you want to install it to, and I have set this as my default library. I've already installed it, so I won't run this bit of code. But once you have it on your computer, then those functions can be used by R, but you need to use the library function to let those functions be available for use. So when we run the library function, which can also be done by just clicking on a button here, that will load it as well. So the package loads, and oftentimes you'll see messages that will provide you with additional information. So this package requires two other packages to be loaded, Permute and Lattice. So throughout this course, we'll be looking at other people's packages and how they can be used to analyze data, ecological problems, to analyze, we'll be using throughout this course, we'll be using many others' packages to investigate ecological problems. And when we begin with a new package, we will follow a pretty standard mode of operation. The first thing we're going to do is we will run a function called help package equals, and we will type in the name of the package like so. So that is help, but we are, instead of passing in the name of a function, we are passing in the name of a package. And when that is run, that will bring up to the help tab the package's help pages. This includes a description file, user guides, package vignettes, and other documentation, package news. It will include a list of each of the functions in alphabetical order and what each function does. So this particular package has a lot of functions, and each function has its own help page. You'll also see a function that, or a listing that will bring you to an overview for the package as a whole. So this particular package is a community ecology package. It does ordination, diversity, and dissimilarities, and you can read the description. So we will be following those orders of operation when we begin to use a new package for each of the videos that we do. Now I want to also talk very briefly about this concept of objects. In our global environment now, we have many different objects, and there are different types of objects. And so I want to spend a few minutes going through a few of the types of objects in R. And it's important to know the type of object you're working with, because if you find yourself in a hole with a coding error, very often it's because you're working with something that is an object that is where R thinks it should be a different type of object. So let's talk about this for a second. So everything that is stored in R is stored as objects, which they have different classes. So here we're going to use the square root function, pass in the number 100, and we will store that as an object called result. And we could have used the assignment. Let's do that alt dash to assign this to a new object here. And equal does the same thing. So here we can see result is stored in as the number 10. Now what class is that? Well, here we can use the class function. We use the class, we pass in the name of the object, and R will tell us that this is a number. There's also integer classes. So here if I say age is 39, that's not me, but I also indicated a little L there. And that little L will indicate that that 39 should be stored as an integer. So here's our age, and you can see 39 with a little L after it. And if we look at the class of that object, you can see that R is returning the word integer. R can also store things as characters. So here we're going to create a vector with 4 names. These are my siblings. I'm going to create this vector and store this as an object called sibs. So if I run this bit of code, we see sibs. We can also quickly see it's a character, it's a vector that consists of 4 entries, just like a row or a column in a spreadsheet. And here are the entries that are there. If we run the class function, we can see that R is storing those as characters. Another type of object is a logical object. So here, let's create an object called test, and we'll ask a question. Is 1 greater than 2? So here, let's look for test. This is an object, and the object is storing the answer false. If we look at the class of this object, you can see that it's stored as a logical type of object. decimals are numbers, and what we would like to do now is to draw some random numbers. So we're going to use this random uniform function. So let's first look at the help page for that. This is the uniform distribution. So this is identical to RAND, open parenthesis, close parenthesis in Excel. And we are going to now run this function and say, give me 5 random numbers. If I run this, there's my 5 random numbers. If I run it again, I'll get 5 new random numbers. So I'm going to run this code, and I'm going to store the output as a new object called 5randoms. There it is. Here it is. It's a numbered vector. There's 5 elements in it, and those are the values. If I look at the class of those, it returns numeric. Dates are another type of object, and dates in computers are stored as numbers, as decimals, but they need a reference point. So you need to know, like, how many days or minutes since, January 1st, 1970, for example. So we can use the date function and pass no arguments into it, and that will store our date for today. If we look at that today, you'll see today's January 6th, Saturday. This is the time and the date, and if we look at the class, it's saying that it is a character. So we can't really add or subtract characters, so if we really wanted to work with dates, we would want to use the asDate function. And there are several of these as type functions that are available in R to convert one type of object to another. In fact, if you just look up as, you'll see a whole string of different possibilities. For example, in RStudio, in the R console, I typed in as period, and you can see that several different functions are possible for this type of conversion. So here we're going to enter in Nelson Mandela's birthday, and we'll enter it in a particular format, year, month, and day, and we'll send that to the asDate function and store it as the object name birthday. There's birthday right there. You can see the value, but let's look at the class of that birthday, and here I'll have to stop my as function here, and you can see now that R is returning this as a date. Now, I wanted to get back to some data sets here, and I have a air quality data set that comes with, it's built in with the R package, and I don't believe I've loaded that yet. So if we run this bit of code, oh, I did load it. It says that it is of class data frame, or it is loaded already. And now we can look at the structure using the str function for this data set here. And I don't want to run the function, I want to pass in the air quality thing. So this is saying that it is a data frame. It consists of 153 records of 6 variables. So it's very much like this chick weight, kind of a spreadsheet type of data set. And this is built in, so it's available for us to use right away. And you can see here that this is an example of a data set that consists of these different columns. So there's a column called ozone, which is storing integers. Another column, solar.r, storing integers. Here's wind speed. It is stored as numbers. Temperature, month, and day are all stored as integers. So this str function provides the structure of the object. I use this function all the time. For me, it's a super helpful function. The other type of object is called a factor, and here we'll load in another data set called chick weights, and we'll look at the structure of this data set. And here's chick weight we had before. Now this is chick weights. This is 71 records with 2 variables. If we open this up, you can see the weight and you can see the primary source of feed, horse bean, linseed, and so on. Well, this column here, feed, is a factor, and it has 6 levels: Casein, horse bean, etc. So these are treated like categories, and so they're characters, but they're also categories. And these are this type of object called a factor. This column is useful if you wanted to do some kind of comparisons, like does the weight of the chick depend on what kind of feed it ate. And so you want to make sure that you look to see if your characters are stored as factors or if they are indeed stored as characters. Okay, the last thing is just vectors. We're going to cover vectors and matrices now. We've already looked at several vectors here. We've got tons of vectors, our 5 random numbers, our sibs, these are all vectors. And one thing you need to know is that they can only contain one type of object. You can't mix characters, dates, and numbers, for example. So let's make a vector called low numbers, and here we're going to use the C function to just combine these numbers. We're basically, just like we're creating a vector of low numbers. Here they are, 1 through 5, and it's got the numbers 1, 2, 3, 5, and 6. So just like a spreadsheet column or a row. Let's try to now create an object called mixed, and let's have the values dog, 10, and true in it. So we run mixed. Here we find it, and what you can see, even without calling this object up, we could look at it in the console. You'll see that everything has been converted to a character because, again, these vectors can only store one type, one class of object. Let's look at our low numbers again, and let's look at the structure of these. And here you can see what is actually displayed in the environment. We can see it's a vector, and we can also see the numbers. Now the other kind of object we will use a lot is a matrix. And a matrix is like a data frame. It's just like these spreadsheets, only it's got an important difference here. Let me open up the chick weights again. Here you see weight is a column with numbers, and feed is a characters. Well, matrices are also this grid, but they can only store one type of class. So this would not work as a matrix because it's storing both numbers and factors. To create a matrix, we use the matrix function. So here we're going to pass in our numbers that are going to fill up our matrix, and this matrix has an argument, n row and n column. And then we want to indicate another argument by row. So we're going to create this matrix, and let me just run this bit of code and then look at it so that you can see how this matrix was created. It's the matrix that has 2 rows and 3 columns. We told R what the values are. So this first argument is the data itself. And in fact, we should look at the help page for matrix. So the first argument is the data. The second argument is the number n row. Then the third argument is n col, and then by row. And I could have made this a little bit more clear by entering in the name of the first argument. So you can see that these numbers 1, 2, 3, 11, 12, and 13 were the data that filled in this matrix. Here we specified 2 rows, 3 columns, and we wanted to fill the matrix in by row. So we didn't go 1, 2, 3, 11, 12, 13. We went across the rows. If we want to look at the structure of this object, we can see that this is a matrix, and we can tell that because of the way that this is written here. It is enclosed in brackets. It starts off with the number of rows, followed by a comma, and then followed by the columns. So row, comma, columns. I like to think of a name like Russell Crowe, something RC, to help me keep in mind that this first part is rows and the second part is columns. And then the last type of object is called a list. Lists are super flexible because they can combine lots of different objects together. So here we're going to create an object called myList and use the list function. So I'm going to put that vector called sibs into this list. Those are characters. And I'm also going to put in my low number vector. So if I run this bit of code, now I see my list is an object in the global environment. If I expand that, I can see there are different parts of it. The first section is called siblings. It consists of a vector of characters. And the second is called numbers, and it consists of a vector of numbers. We can just type in the name and R will return this, and this actually helps give us some clues about how to get something out of this object. I find that a lot of my mistakes with R are in dealing with creating an object and then changing how that object works, or extracting or putting something new into that object. Well, the structure function will help us to see how that is organized. So here you can see that when I return this object, I've got a section. It starts with this $, and then is named siblings, and here's another part of that called numbers. So if I wanted to extract the numbers, I would start typing my list and then indicate that $, and then press and then enter the numbers, and it will return that bit of that list. You can also start typing this in the console, my list, and if I put helps if I spell it correctly, my list, if I start looking at that and I type in that $, I can see that there are some helpers here where I can just use my tab key and then enter, and it will help me to quickly generate those responses. Now remember that chick weights data frame we looked at? We also looked at this data frame. Well, data frames are actually lists. They are just lists that consist of many vectors that have the exact same length. So if we look at the structure of chick weights, we can see it's a data frame, and it has 71 records and 2 variables. So here are the vectors right here. It's just taking each column basically of the data. Each column can have only one type of class, and it's just combining them together into this object called a data frame. Super important structure for working with data analysis. Here we are. I just wanted to quickly show you a little bit more back to this package called Vegan. I wanted to show you how we use some of the functions in different packages. So I wanted to take a second here. We'll load the library Vegan, and we'll call up its help page once again. And here they have included in their package some data sets. So this data set BCI is Barrow Colorado Island tree counts. So if I use the data function, I can load that, and here you can see Barrow, Colorado Island, BCI, 50 records with 225 variables. If we open this up and take a look at it, you'll see that the rows are the different sites, and then we have the number of individuals of each tree species written across the columns. So this is a fairly extensive data set. And you'd want to, of course, look at the help page for that data set before you start using it. But we're going to use a function in Vegan called species number, which just will count how many species are there in each of these different plots. So we'll look at the function name, species number. Here it is. This tells us how we want to count our species. And this has an argument x, which is you pass in a matrix-like object. And then we don't have any groups in that data set, but this third argument is called margin. This is the margin by which the index is computed, and the default is 1. So again, very, very important for you to know what the defaults are, because if you run code and are unaware of that, you may not get the answer you are expecting. So in this case, we're going to run this, get our species number. Margin equals 1 is going to be by row, and then margin is 2 would be down the columns. And we stored this object here called S. And you can see here that it is just a big long vector, each of the 50 sites, telling us how many species were in each of those sites. So that's an example of a package that will take in a data set that's like a data frame or a matrix. Now there are some packages that require different kind of object that are called S4 objects, and they're specially formatted. To highlight that, we're going to illustrate this with the package unmarked. So this is a package that is used to estimate occupancy in different species across the planet, wherever you want to go. Now if you have not installed it, you'll need to go to the Packages tab, choose Install, and then type in unmarked and install that into your library. And then once it's installed, you can run the library function, and then of course the package will be loaded. It will load in the required packages that it needs, and then we'll look at the help page. So this is a package. It's models for data from unmarked animals. Here are the help pages, the user vignettes and so forth, the names of the functions in alphabetical order, a brief description of what they each do. Now this package includes a data set that's called frogs. And in fact, we can type in help frogs to get an idea of what this data set is. So this is a data set that consists of it's from Delaware, and it's a frog monitoring program collected in 2001. So this tells us how we can call this data set up. So we'll load this data set, and we will look for the data set called frogs. And it is available for us to use at this point. Let's first look at the structure of this using the str function. And what you can see here is that the frogs object doesn't appear in the global environment. Instead, several different pieces of information are stored in this object called pcru.bin data y, bin data y. There's different species here. So these are two different species of frogs, And each one of these objects is storing different bits of information about a frog survey. You'll see here that they're held as a promise, meaning they're there, but they won't appear until we begin working with them. Now what I want to do is look at this pfer.bin. Let's look at that. We'll just highlight that and run it. And what you can see is there's 130, these are 130 study sites, and we are documenting the presence or absence of these different frogs. And so these are listed by their scientific names. So this is site number 1. On the first visit, this frog was detected, the species was detected, the species was not detected, and the third survey, the survey was not conducted. And you can see it's just a grouping of zeros and ones. Well, what we're going to do is use a function that will take this raw data and turn it into what is called an unmarked frame object here. We're going to call it PFERUMF. We could have called it anything, but this stands for unmarked frame. And I just wanted to show you this so that you get a sense of what this thing looks like. You can see it in the global environment here, and this is an object that has a formal class unmarked frame OCU. And if we expand this object and look into it, you'll see these symbols here that begin with an @ symbol. These are called slots. So this is an S4 object, and the authors of this package have created the functions so that they are expecting you, if you're analyzing some occupancy data, they're expecting that the first thing you'll do is put your data into this unmarked frame type of object, and when you then do your analysis, it's going to expect this object to be passed into that function. So let's look at the structure of this object with the structure function. So here it says formal class, 5 slots. These are the slots that begin with the @ symbol. And the authors of a package that use this S4 type of structure will often provide many different functions for digging into these objects and extracting the information that is needed. So that is an example of an S4 object, and there are packages that we'll be using that use this type of framework, so you won't find the words list and things like that. Instead, you'll see slots, and these slots will contain perhaps they can contain data frames or matrices or whatever. So, so for example, this Y vector right here is stored as a matrix, 130 records and 3 columns, and you can identify that as a matrix with this bit of line right here. So the stuff that's stored inside might be familiar to you, data frames, matrices, etc. But they are stored in this particular type of structured object, and the authors of this package require this framework to use their functions. So just something to be aware of. That covers our very brief introduction to R and RStudio. As I mentioned at the beginning, there's no way to learn R in a couple of hours. Learning any new program takes time, and as we work through the different videos, we'll be spending lots of time in the package help tab, help section, and we'll be working through many of the example files. It's the best way to learn how to use a new program. Okay, we'll see you next time.